Most of us use one every single day, but let's be honest, for many, it's a complete black box. It's this metal heart that just roars to life and takes us wherever we need to go. So today, we're going to pop the hood and unpack the incredible process that turns liquid fuel into pure, unadulterated motion, the internal combustion engine.
I mean, it seems so simple, right? You just press a pedal, and the car, well, it goes. But what is actually happening under the hood to make all that possible? What's the secret sauce behind all that power? Well, today, we're going to answer that exact question.
All right, so here's our game plan. We're going to break this whole thing down into 4 parts. First up, the big idea. How do you turn fuel into motion? Then we'll walk through the 4-stroke cycle of a regular petrol engine. After that, we'll see what makes a diesel engine tick differently. And finally, we'll connect all those moving parts to how your wheels actually turn on the pavement.
Okay, so let's start with the really big picture. At its very heart, an engine is a machine designed to do one and only one thing: to take the chemical energy that's locked inside fuel and turn it into powerful, useful mechanical energy.
And it's kind of wild to think about, but the basic blueprint for most car engines has been around since 1876. Seriously, it's called the Otto cycle, and it's basically the recipe for creating a constant, controlled series of tiny explosions or combustions to generate power.
So how does that cycle actually play out inside a standard petrol engine? Well, it's this beautifully efficient 4-step dance that happens over and over again inside each cylinder. You can almost think of it like a 4-stroke symphony.
And these are the 4 movements of our symphony: intake, compression, power, and exhaust. That simple, repeating loop, it is the key to absolutely everything.
So, it all kicks off with the intake stroke. What happens here is the piston, which is basically a plunger inside the cylinder, it moves down. This creates a vacuum which sucks in a fine mist of petrol mixed with air. Think of it like the engine taking its first big, deep breath. Then comes compression. The intake valve snaps shut and the piston shoots back up, squeezing that air and fuel mixture into a tiny fraction of its original space. The pressure inside just skyrockets. All that potential energy is just coiled up, waiting to be released.
And now, for the moment we've all been waiting for, the power stroke. Right at the peak of compression, the spark plug fires. That one tiny spark ignites the whole pressurized mixture. Bang! The explosion is so powerful it slams the piston back down with incredible force. This is the single push that actually creates all the engine's power.
And finally, we've got to clean up the mess. That's the exhaust stroke. The piston moves up one last time, but now the exhaust valve opens up. The piston pushes all those burnt gases, all the waste from that little explosion, out of the cylinder and into the exhaust pipe. And just like that, the cylinder is clean and ready to do it all over again.
Okay, so now that you've totally got the petrol engine down, let's look at its bigger, brawnier cousin, the diesel. Now, it's not a totally different animal. Instead, think of it as a really fascinating variation on the same theme we just learned.
Just like a petrol engine, a diesel uses the exact same 4 strokes: intake, compression, power, and exhaust. The rhythm is pretty much identical, but the way it makes that bang happen is completely different.
So, if it's not using a spark plug to set off the explosion, then what in the world does it use? Well, the secret is all in the compression stroke itself.
And here it is. This is the key difference. A petrol engine needs a spark to ignite the fuel. A diesel engine, though, uses pure brute force pressure. It squeezes the air so intensely that the air itself becomes incredibly hot enough to instantly set diesel fuel on fire the moment it touches it. No spark plug necessary.
And that one big difference, it creates a few other changes in how things work. For one, during the intake stroke, a diesel only pulls in air, no fuel. The fuel itself, which is made of heavier stuff, is only injected right at the very last second of the compression stroke, where it just spontaneously combusts in that superheated air.
Okay, so we've got these pistons just flying up and down, creating all this power. But how do we get from that frantic up and down motion inside the engine to the smooth forward roll of your car's wheels?
The magic piece that makes this all happen is called the crankshaft. The best way to think of it is like the pedals on a bicycle. Every single time a piston is forced down by that power stroke, it pushes on the crankshaft, forcing it to rotate. It's the perfect mechanism for turning that straight line motion into the spinning motion we need to turn the wheels.
And remember, this whole dance, it isn't happening slowly.
This entire four-stroke cycle is repeating in multiple cylinders thousands and thousands of times every single minute. All those individual little power strokes just blend together into this smooth, continuous river of energy that moves your car down the road.
You know, when you think about it, the internal combustion engine was, without a doubt, one of the most transformative inventions in human history. It literally defined a century of movement and progress. Which brings us to the big question. What comes next? What's the technology that's going to define how we all get around for the next 100 years?